Here's the round 34, day 2 Bellwork answer. Question A, draw the condensed structural formula for 2-methylbutane. We want to draw the condensed structural formula. That's a picture that looks like question C. So take a look at that drawing in question C and just see how that's made in general. Notice how it has dashes to show connections, but it doesn't have dashes showing how hydrogens are connected to carbons. The letter H is just written directly next to letter C. So that's our goal. That's what we want to end up with. But for a lot of people, it's easier to draw a complete formula first and then turn it into a condensed formula. I recommend that you do that until you get really good at picturing in your mind how things are going to be connected, how many H's would be connected to any carbon atom, how to make the dashes, and so on. So for question A, let's make a complete picture, and then we'll turn it into a condensed. So the parent chain of this molecule is butane, a 4-carbon chain. So we'll make 4 carbons connected with dashes. There is one branch on this parent chain. That branch is called methyl, and it's attached to the second carbon on the chain. Methyl is a 1-carbon branch. So at the second carbon, we'll connect a branch on there that has 1 carbon in it. Now let's think about all the hydrogens. Where is there room for hydrogen? This will have a hydrogen connected here, here, and here. This carbon only has room for 1 hydrogen. This carbon down here at the bottom can have 3 around it. The third carbon in the parent chain has room for a hydrogen here and here. And the last carbon has room for 3 hydrogens to be attached. That's the complete drawing, right? Where every hydrogen is attached with a dash. So let's just redraw that as a condensed formula. The first carbon in the chain has 3 hydrogens connected to it. We can call that CH3. And then you put a dash and you move to the next carbon in the chain. That second carbon has only 1 hydrogen attached to it, so CH. Now the third carbon in the chain. This carbon has 2 hydrogens, so CH2 is its condensed version. And the fourth carbon in the chain has 3 hydrogens, so CH3. Now I need to show the branch. So coming out of here, we have CH3. This is the same thing that I drew over on the left, but this is the condensed version. Okay, again, if you can go directly to the condensed version, that's awesome. That's what we're trying to do. But you just really need to think hard about how many H's does any of the carbons have. Okay, question B, draw the condensed formula for 2,3-diethyl pentane. The parent is pentane, 5 carbons. There are 2 branches. I know there's 2 branches because of the prefix di. Each of the branches is an ethyl, and the branches are attached at carbon 2 and carbon 3 off the parent. So off of carbon 2, let's draw an ethyl branch. An ethyl branch is made of 2 carbons. It's carbon and then a carbon. Off the third carbon in the parent, there's another ethyl branch. Now you can draw it underneath or you can draw above. This isn't even our final answer, right? We're just kind of sketching what the complete version looks like so we know how many H's to put with anything. Now this first carbon on the left seems to have room for 3 hydrogens to go around it. The second carbon has room for 1 hydrogen. On this branch down here, this carbon has room for 2 H's, but this last one has room for 3 H's. Okay, the third carbon in the parent can have a hydrogen here. The branch can have a hydrogen and a hydrogen, but the last carbon on the branch can have 3 hydrogens. The fourth carbon in the parent has room for 2 hydrogens, and the last carbon has room for 3 hydrogens. And I'm not even drawing the dashes on this because, again, I'm just doing a quick sketch to try to figure out how many hydrogens are associated with each carbon. So now let's do the condensed version. Our first carbon in the parent has 3 hydrogens, so CH3 is its condensed form. Then a dash, let's move to the next carbon, CH. Okay, and then a dash, and the next carbon is CH. Then a dash, the fourth carbon in the parent chain is CH2. And the last one is CH3. Okay, now the branches. Off that second carbon, we have CH2 and then CH3. And off the third carbon, CH2 and then CH3. Here is the condensed version of that molecule, whereas the sketch I had made on the left side was the complete version. Now question C, write the name of this alkane. So the first thing you need to do when you name an alkane is find the longest chain. Now, as a hint, it's kind of been numbered for us. The longest chain starts at the left and just goes straight across the center. And that's not always going to be the case because carbon chains can twist around, turn corners, and so on. But in this particular drawing, that is the longest chain. So there's 8 carbons in the parent chain. We know that the parent is called octane. Now, in front of that word octane, you will put names of any branches. There appear to be 2 branches. At the third carbon on the parent, there is a methyl branch. At the 5th carbon on the parent, there is an ethyl branch. Branches are listed in alphabetical order, so ethyl is going to be listed before methyl. And when you name a branch, you also indicate a number to say where it's attached on the parent. So we have 5 ethyl, and then 3 methyl, and then octane. And you want that to all fit together nicely so it looks like one big long word with some numbers and some dashes in it.